All right, we are going to finish our section on air masses and fronts. The text, the whole section is 72 to 79, but we're going to start on page 76 and read through 79. We're going to read about fronts today. You can see up here in this image, there are two of the fronts, and on the next page are the other two fronts. I know in your book it's just one, layout, but we are going to start here. I wanted to show you and talk about these models here. So this first front here you can see is a cold front. And remember, cold air is more dense than warm air. So the cold front, when you have a cold and a warm front, meaning the cold front will move under, the warm air front will be pushed up. Okay. And along that front, you will get clouds forming. Okay. That is when the cold front is moving. Cold fronts tend to move faster. So when they run into a warm front, you get a quick change in temperature and you can get storms. A warm front tends to move slower. The same thing will happen when a warm front heads to a cold front. The warm front will still be pushed up and the cold front will go down below, but it's slower because the warm front moves slower. So you'll get more stratus or nimbostratus type clouds where you'll get gray for a while and drizzle and lighter rain than a storm. Going down to our other two fronts here, we have a stationary front. It's interesting. It's when you have already a cold and an air front that have met, and then when you have a cold and an air front that meet, but neither one is really moving faster, and so they sort of have a standoff. It's stationary. And again, you'll get that warm air will eventually be pushed up and you'll get cloud formation and storms. And then an occluded front is where you actually have a cold front or a cold air mass and a warm air mass, and then another cold air mass comes in and it pushes the warm air mass up and you get some storms in there as well. But let me go back up here and let me start to read about types of fronts. Colliding, or air masses that are pushed together, colliding air masses can form four types of fronts: cold fronts, warm fronts, stationary fronts, and occluded fronts, and we'll talk about those. The kind of front that develops depends on the characteristics of the air masses and how they're moving. So cold fronts, as you've learned, cold air is dense and tends to sink. Warm air is less dense and tends to rise. So when you have a rapidly moving cold air mass that runs into a slow-moving warm air mass, the cold, dense air slides under the warm air. The warm air is pushed upward along the edge of the cold air, as shown in that figure above. As the warm air rises, because you have that warmer air, it's holding more moisture. As it rises, it will cool. And because the warm air is holding more water vapor than the cool air, the rising air will reach the dew point, the temperature at which the water vapor of the air will condense into droplets of liquid water or form tiny ice crystals, which of course then is a cloud. Clouds form. If there's a lot of water vapor in the air, heavy rain or snow may fall. If the warm air mass contains only a little water vapor, then the cold front may only be accompanied by cloudy skies. Since cold fronts tend to move quickly, however, they can cause an abrupt or a rapid weather change, including thunderstorms. After a cold front moves through an area, though, you'll have colder, drier air that will move in, bringing clear skies, a shift in the wind, and lower temperatures. A warm front. Clouds and precipitation also accompany warm fronts. At a warm front, though, a fast-moving warm air mass will overtake a slower-moving cold air mass. Because the cold air, again, is denser, the warm air will rise over the cold air. If it's humid, again, light rain or snow. If the warm air is dry, you may just get some scattered clouds. Because warm fronts move slowly, the weather may be rainy or cloudy for several days. After a warm front passes through an area, the weather is likely to be warm and humid. Stationary fronts. Sometimes cold and warm air masses meet, but neither one moves the other. The two air masses face each other in a standoff. In this case, the front is called a stationary front. Stationary, not moving. When the warm air and cold air meet, water vapor in the warm air condenses into snow, fog, rain, or clouds. If a stationary front remains stalled over an area, it may bring many days of clouds and precipitation. And the occluded front. The most complex weather situation occurs at an occluded front, where a warm air mass is caught between two cooler air masses. The denser, cooler air masses move under the less dense warm air mass and push the warm air upward. The two cool air masses will meet in the middle and they may mix because they will have a similar temperature and density. The temperature near the ground will become cooler. The warm air mass would then be cut off, or the word is occluded or separated from the ground. As the warm air cools and its water vapor condenses, the weather can turn cloudy and again rain or snow may fall. Now we have these other things called cyclones and anticyclones, and it's not what you're thinking about, like a big storm. But a cyclone or anticyclone is just an area of high pressure or low pressure. An air mass collides to form fronts, the boundaries between two fronts. Okay, that's where you'll get this happening. So the boundary between the fronts sometimes becomes distorted. This distortion can be caused by surface features such as mountains or strong winds, such as the jet stream. When this happens, you get bends along that front and the air begins to swirl, and the swirling air can take a low pressure center to form. If you look at a weather map and you see areas marked with an L, and we've been looking at the pressure, like we know when the pressure is dropping, not as good of weather is coming, less preferred weather is coming. The L stands for low and indicates an area of relatively low air pressure, meaning you're going to have warmer air rising, right? A swirling center of low air pressure is called a cyclone, from the Greek word meaning wheel. As the warm air at the center of the cyclone rises, the air pressure decreases. Cooler air blows towards this low pressure area from nearby areas where the pressure is higher. So you get this cooler air feeding this warm air cyclone going up. As shown in figure 6, winds spiral inward toward the center of the system. Recall that in the northern hemisphere, the Coriolis effect deflects winds to the right. Because of this deflection, winds in the cyclone spin counterclockwise in the northern hemisphere when viewed from above. Cyclones actually play a large part in the weather of the United States. As the air rises and it cools, it forms clouds and precipitation. Cyclones and decreasing air pressure associated with clouds, wind, and precipitation. That's why we've talked about when we see lower pressure or pressure dropping, we know that less preferred weather is coming. And the reason is that warm air will rise and the humidity will condense and potentially bring rain. Now, anticyclones are just the opposite. An anticyclone is the opposite of a cyclone. It's a high pressure center of dry air. So you have this cooler, denser air coming down. Now, because of that, you're not really getting any moisture in that. So you have high pressure, which gives you better weather. Anticyclones are usually called highs, or H on a weather map. Winds spiral outward from the center of the anticyclone, moving toward areas of lower pressure. Because of the Coriolis effect, winds in an anticyclone spin clockwise in the northern hemisphere. Because the air moves out from the center of the anticyclone, the cooler moves downward from higher in the troposphere. As the cooler falls, it warms up, and so its relative humidity drops. That descending air, the air that is coming down in an anticyclone, generally causes dry, clear weather. Now we have our highs and lows on our map here, and you can see the satellite image shows this low pressure area, the cyclone here, right? And over the northeast, the satellite image shows a low pressure cyclone over the northeast and high pressured areas over the south and the west. High pressure areas will have clear skies. Now I know they're showing snow, but that just means like you might be in a Colorado area where they already have a lot of snow. And then in a low area, you'll have precipitation occurring. All right, that's it for this section. I will see you guys on the next one. We have one more section for this unit. Bye.